Hey guys, can you hear me? Can you just acknowledge on the chat if you can hear me? Am I audible?
Yes, ma'am, you are.
I am. Alright. Good evening, everyone. How are you doing? How is the day going so far? Only Gayatri is able to hear me? What about others? Gunjan, Snehal, Jnaneshwari, Kshitija. Are you guys able to hear me? Can you please try acknowledging it in the chat if you can? All good. Okay. You guys are having exams now, is it? Or in a few days or something? What's the scene for exams? All okay. Some of us are having exams as well. We are in different colleges because, as far as I know, March start is basically when your engineering exams, Viva, and practicals are going on. Okay, good to know. So, you guys should be finished by this month end. Cool. Anyways, let's start. So, if you are already having exams, just wishing you all the best to anyone who is having exams, whatever kind of is fine. So I'll just share my screen with you guys. I just let me know in the chat if you can see my screen. Just a second. Is my screen visible to every person? Every single person present here? People who just joined? Yes. Others? Everybody can see my screen? Others, can you guys see my screen? Kshitija, Anushka, all of you guys. I'm talking to every single person present.
Yes, ma'am.
Okay, alright. Okay, cool. So let's start off. Before we start off with the missed half part of last lecture, actually I have internet issue, but you are not audible and this. Okay. If today if you have any issues, just let me know. Ping me in the middle whenever you're not able to hear me, so that I know what part you missed and I can tell you. The video is usually recorded and you will get it on YouTube. At the end, just remind me. I'll show you where exactly it is available on YouTube. Yaneshwari. Okay. All right. Cool. So before we start off with today's topic for discussion, let's have a look at the storytelling part that we usually go through. So in the previous session, we walked in through AI in healthcare. We were talking about how AI helps in identification of lung cancer. Right? Today, let's do something new, something creative, like AI in videography. You guys have seen reels, right? So many reels on Instagrams are just floating. Have you seen the different format they are using? Do you know of any video editors, guys? Maybe let's say you were creating some reel on Instagram. So do you use any video editors? Any video editors you can name for me? Whichever you use. One of them I will name is Adobe is one. One of them I have heard of is VN. Can you name any video editors? Any that you have heard of or used, maybe while creating videos for academics? Kind Master, yes. Anybody else? Have we heard of any video editors? We are talking about AI in videography. In short, is that an app? In short is an app. I've heard of it, but I thought InShot was a camera. I'm not sure if InShot app is also there. Yes, okay. I'll have to check it. So Kind Master, InShot, how all of these are apps. They allow you to do so many things in video. Have you seen there is something called as a Photoshop wherein you can actually erase the background or put a new background. Canva, yes. So all of these are video editors that technically use AI. You might have not thought about it. So AI is just revolutionizing the way videos are shown to people. If you see in the olden days, not very old, like a few years back, the videos are pretty, like monotonous, same background, same tone, and all of that. Now the video processing has become faster because the editors that you are using have AI built in them. One of the most significant ways AI is used is through automated editing tools. We have so many editing tools, like you can remove the watermark if you have any, you can blend the picture to the background, or you can remove the background, or you can remove the people in the background, right? So if you go to the statistics on how AI actually has developed over the years, there was a survey report carried out by Zion Market Research. So global video editing software market size, I'm talking about the value, it was around $790 million in 2018. And it is expected to reach around $1,000 million by 2025. So you see the eventual increase in the graph just because AI was integrated with the video editing apps. So when you adopt AI powered video editing tools, it gives you advantages like more I can say efficiency of the outputs, more beautiful outputs is one word we can put, and less amount of time required. Then a survey conducted by Deloitte also found out that 63% of consumers like you and me, we are likely to watch videos if it includes AI generated effects. See, whenever you go on any app on Play Store, right? You are not installing the app that looks all boring. You will install the app that looks nice. That's a human tendency, to get attracted to things that look nice, maybe colorful and all sort of. So AI is like a boon in terms of videography. So to watch a video, if it includes AI generated effects, 63% of the consumers are likely to watch it. So these were the statistics taken from reports from Deloitte and Xeon Market in 2018 and 2019. Now, the recent thing that we heard of AI in videography for generating voices for films and ad. Have you heard of any, or maybe have you seen any series wherein there is dubbing required? Any series or any movies can you name in which dubbing or maybe dubbing is giving voice for any character? Can you name a couple of movies in which Lion King? I was expecting that as the first answer. Okay. Any series also is fine, or any cartoon characters if you can think of any cartoon characters or series. Frozen, yes. Minions, yes. Despicable Me, yes. So all of these, you know how much time it is required for dubbing. Like you have to see, then you have to manage your tone over there, right? So AI being used in videography is also able to generate voices for both films and art. Doraemon, yes. So AI being used in videography and ads through a technology called text to speech. It's like you give it the text, you tell it what exactly is the text to be, like said out loudly. AI will do the job for you. With this text to speech algorithm, we are able to convert the written text that you want to give to the AI into spoken words. So that is basically what we call as a text to speech. So this can save time and money both. You do not have to pay for the actor who is actually dubbing, and you do not have to, like waste time to first write the script for the actor and the actor going to the script practicing it and all of that. And it also allows greater control over the tone and pacing over the voiceover. So yes, AI helps you to do that also. The tone, the pitch, the loudness, the anger, the emotions, all of them are taken care by AI itself. There was this current news going on. Let's talk about a technology called Finaki. So Finaki is a technology, the model. It helps you to take your text prompts, create different connections between them, connect the point one after the another, and then it will create a visual story. Basically, it is doing the job of a director. How the director has to direct all the things right from the start to the end, movie start, movie middle, then movie end, all of that. So creating the entire movies without a director, but using AI, where AI is the director. So from the outside, it seems as if AI reads input like a normal film script and decides how to translate the storyline into pictures. So it is the decision of AI. It will read the prompts or the inputs given by you, and it will decide, okay, this can be the output. It will give you a variety of output and you can choose from them. So Finaki was one technology recently. In the Discord channel, I'll be sharing some research papers on Finaki. Just have a look. It's pretty cool because we live in a generation where we do not talk about theoretical stuff. Textbooks seem boring to us. Trust me, I'm one of you guys. But when we actually look into the videos, because visual effects are something that humans are more attracted to, So then it makes it interesting and easy to learn. So I'll be sharing the research papers and some YouTube videos, or you can just go up to YouTube and search for Finaki. You will get tremendously amazing results. You can actually look at how it is being directed and what are the AI outputs. So that was all for storytelling for today. So does any of you over here does any videography or is into videography or has practiced? You guys mentioned Canva, in short, and many things. Kind Master. Any of you is actually doing those? Any of you has actually used those? And if used, so for what? Like I use VN for blending the images to the background. Sometimes I want to remove the people from the background or maybe blend my image to the background. So I use VN for that. What about you guys? Any of you uses any of these softwares, editors that you have mentioned? You have just heard of them, is what I'm thinking. Okay. Seems like you have just heard of them. Okay. So let's go ahead with the session today. I hope everyone is prepared with the two topics given. One of them was unsupervised learning, and one of them was reinforcement learning. Going back to what we did in the previous session, we had an introduction and a detailed information about machine learning and supervised learning. So today we'll just bring in some part of supervised learning as well. All right. So let's begin. So before we start on, everybody present over here is present on Discord is what I'm assuming because all the quizzes will be done there. And Gayatri, Jnaneshwari, right? So that's the YouTube link, Jnaneshwari. I'll just share it with you. So on that YouTube link, if you go, you should be able to find out all the session recordings. So even if you miss any session, you can go there and have a look. There you go. That's the YouTube channel. So if you want, you can keep it subscribed so that whenever a new video is uploaded, you can have a look at it. All right. So guys, in the previous session, the homework given was to create a logistic regression model, and some questions were asked over there to research on NumPy and what is the Ravel method. So, how many of you guys over here actually did the homework? I would just require a yes or no, not a silent pin drop silence. No, I would require a yes or no. Even if you haven't done it, it's fine. I'm not reducing your marks. So, people who have done, can you try putting a yes? And people who have not done, please try putting a no, so that I can get an actual count of how many people have done. Quick, quick. There were two homeworks given, one for logistic regression and one for report making. So I'm talking about logistic regression over here. No, okay, no, no, okay. Others? You did not attend. Please have a look at the video once, Kshitija. No. You can play it at a 2x speed. That's the fun part of it. No, okay. So I'm assuming over here whoever present have not done the homework. Okay. But do we recall what exactly was logistic and linear regression? Can we just take 5 minutes to recall? What was linear regression, guys, versus what was logistic regression? And the linear regression, what are we trying to predict? Okay, sure. We'll upload on GitHub till tomorrow. Okay. Does anybody remember what exactly were we talking about in logistics versus linear regression?
Ma'am, in regression, we get
Mhm.
the value,
Value.
our result is in the form of a value based on the
Correct.
previous data. And
Correct.
in logistic regression, we either get yes or no as our
Cool.
result.
Cool. So in linear, we are predicting a value, whereas in logistics, we are predicting yes or no. Example is in linear, you can predict your percentage based on a range. And in logistic, you can just say, did I pass the test or no? So yes or no. So I'll just go to the project. Let us just have a look so that when you actually do it, you don't have any issue. You remember I had given you a data set, a CSV file. So if you open that, this is the data set. The input was score. Depending on that, your model has to predict the output. When accepted is zero, meaning no, it wasn't accepted. When accepted is one, like yes, the person with the score this was accepted. Okay, that is the way your logistic regression should work. So the first thing we had done is I will just try to make it in parts so that you guys are able to understand it. The first thing was importing the libraries. Can somebody let me know if we just try to recall why exactly is the pandas library used? The first line of my code says import pandas as a nickname PD. PD is the nickname we usually give to it so that you do not have to say pandas every time. Does anybody remember why do we use this library pandas? For calling pandas from Japan or for something else? Anybody, why do we use pandas?
For using the inbuilt functions.
For using the inbuilt functions, all right. So pandas, yes, is an inbuilt library, of course. Pandas specific usage is to read the file, or to be very specific, to read the CSV comma separated file. This is a comma separated file, no, one column comma second. So that is the job of a panda. Then let's not talk about this for now. The second thing is after importing, I have to actually read the CSV file. No? So I imported it with PD, right? That was the nickname I gave it. So PD has the function read underscore CSV, as you said, and in there provide the link, like what is the data you have to read. Now, if I just do a print df, like whatever is there in df, you see all the data is present in df, literally all of it, whatever was present in this link. Step one, read the CSV file. Step two, now see, you have to give input to the computer and the computer should predict the output for you. So for that, technically, this column, the first column, the row column should be separated, right? And the accepted column should be separated. So in order to do that, we use a function called toList. It is going inside df, the variable that was having your data, and then inside df, it is going inside the column named score. So it went inside score and converted it to a list. Now, if I show you, if I print this score list, just have a look. It is just printing the very first column, which is for the score. Same we did for accepted. If you print accepted, it will show you the another list accepted. It will show you the another list which has all the accepted values 0, 0, 1, and all of that. Now the second thing we need to do is we need to actually create a logistic regression model. So we need to import that from a library called sklinear, and there's a sublibrary linear underscore model. So that will help you to import the logistic regression from the required library. I had asked you to research on NumPy. So let me just have a quick call on what is NumPy. NumPy is an open source library. Library is predefined codes available for it. It is designed to perform complex mathematical things, image processing, computing, statistical operations, etc. Basically, NumPy will help you to do all the mathematical stuff for this list that we are talking about. This list, this entire container. So the first thing we did was we reshaped the list. Which list? This entire list. Into what dimensions? So when you say dimensions, it is supposed to be rows and columns. So you're like, whatever number of values we have, those many rows and how many columns? One. When I say len of score list, meaning the total number of items present in the score list. This can be 100, 200, so on. So I'll get 100 rows. And how many columns? Just one. So if I just print one value for you guys, print x, so see how it has reshaped it. So many rows, right? But just one column. Can you see? So because we put no so many rows, how much ever the length is, and just one column. So you need to reshape it in a manner like this to actually train your logistic regression model. Then you created a model, you fit it with some data, meaning model was empty, you put some data into it, you created a function. Now, logistic regression has a formula 1 divided by 1 plus e raised to the power minus x is the formula given for that. So that is how we written it 1 upon 1 plus. How do you do exponent e raised to? That cannot be done directly. You will have to use numpy or np for that. The one that we have imported. It I told you it performs mathematical equation. Isn't this a mathematical equation? 2 raised to 2 is 4. Then lastly, you will have to apply the function and the formula. This is very much equivalent to y is equal to m multiplied by x plus c, if you remember from the previous session, the straight line formula. So mx plus c. You see, the first one is m, this one is m, that's your input x, plus c being your intercept. Now what was ravel? Ravel is also one thing I asked you to search. So ravel is basically a module of numpy. The numpy of Python provides a function. Ravel is a function from numpy, which is used to change a two-dimensional array. When I say two-dimensional, meaning there can be a possibility where you have a list inside another list, or a list inside another list, another list. There can be many lists. So Ravel over here is just protecting those things and making sure that your array is a single dimensional array. One dimensional flattened array is what I'm talking about. So now I have my Ravel done. The last thing you have to do is take the input from the user, like what all scores have you got. Apply the function over here in a variable, let's say just chances, and just check if chances are less than 0.01. It is not accepted. Student is not accepted. If it is greater than 1, it's surely yet that yes, the students will get accepted. If it is less than zero point 0.5, then no, might not get accepted. But if it is greater than zero point 0.5, the student might get accepted. So these are all the few different cases I created. You want, you can create different cases and try to run your code. So that was the homework I gave for logistic regression. So guys, was the logistic regression homework clear? Will you be able to do it most probably in a day or two? Everyone, is the fundament okay? Is the fundamental of logistic regression clear? Will you be able to do the codes, guys? A yes or no in the chat would be fine. Okay. I've already shared a screenshot for this one in the chat. Just have a look at it. Like I had shared it in the after the previous session. All right. So let's go. That was a quick discussion about the previous session's homework. Now let's dive into today's stuff. So, introduction to unsupervised learning is what we are going to have a look today. We'll get an overview of unsupervised learning and some algorithms of unsupervised learning. So, there is one activity for you guys. This is for all of you, okay? There's a bowl, and I can see fruits like there's a watermelon, there's a strawberry, there's the black grapes we have, there is cherry, there is kiwi, and I think that's a orange. Yeah, that's an orange. Okay, so these are the few fruits I have. What I want you to do is I want you to group them the way you want it to. You want to put all the red fruits in a different group and other fruits in a different group. You can group them, or if you want to group them in an alphabetical manner, let's say I want you to create 3 to 4 groups. What I want everybody to do is go in this chat box and try to group them according to your opinion. Go ahead. Take a couple of minutes, but group them according to. I do not have any restrictions the way you want to group them. I'm just giving you a bag of mixed fruit, and I've asked you to group them on similarities that you think are okay. So how would you go about it? Let's say you do not have any prior knowledge of fruits. So how would you group these? Come on, quick. You can just say group one and the name of the fruits, then group two and the name of the fruits. Provided you have a group three, you can put it. Based on color. Okay, so what will be your groups? Segregate them into groups. Think of yourself as a developer at this moment. So segregate them. Your opinion is okay. You want to group them based on color. So how many groups will you create, and in which group, which what all participants would you have? You can say group one if you want. Give it a name and give me the name of the participants you all have in group one. Group two, if you want to give it a name. So group one is watermelon, strawberry, and cherry. Okay. Okay, Prajakta has grouped one for based on the type of vitamins. Okay, at this moment, if you know how many vitamins are present in it, group them. Let's see. Like how Prajakta said in group one, she'll have watermelon, strawberry, and cherry. We'll go to according to what parts did you group them. We'll go to that part. First, let's create groups. Gathering same looking fruits. Okay. Do we have same looking fruits though? Yeah. Cherry and strawberry almost look the same, at least to me. And so I think there's a lychee also somewhere in the corner. Cool, Prajakta. What about group two? What about others? There's Gayatri, Shitija, Sakshi, Amruta. Based on taste. Okay, okay, that's a good one. Others, on what parameters are you going to group them and what would be your groups? On the basis of number of seeds. Okay, that is one or many. Yes, another cool one. So you see, you are trying to develop various scenarios in your head. Anything else? Do we have anything else? So Samriddhi said she is doing it on the basis of colors. Uh, Suvarchala said she's gathering same looking fruits. Same for, oh, Suvarchala said for vitamins. Vitamins. Nehal said same looking fruits. Sakshi said based on taste. Jnaneshwari saying based on the number of seeds, one or many. Gayatri said based on the season of availability, yes. So Prajakta, cool. Since you have grouped them, in your group one you have watermelon, strawberry, cherry. In the group two you have blackberry only. In the group three you have kiwi, and in the group four you have orange. So what was your way? I mean, depending on what parameter did you group them? Did you group it on the basis of taste or vitamins or same looking or color or something else that we do not know about? Depend colors, all right. So you see, all of you had different scenarios, right? I didn't give you a restriction. I just said, Jalo, group it. So you had different scenarios in your mind. Some did it on the basis of color, some did it on the basis of number of seats. If possible, we can also do it on the basis of size, like cherries and lychees actually are smaller in size. If there was a watermelon, so it's bigger in size. Depends. Some of you also did it on the basis of seeds. So you see, you have so many, what I can say, wide range that you can make your decisions on. So when you are encountering this, we talk about something called as unsupervised learning. So if you try to connect this activity with the word unsupervised learning, oh, what is the takeaway from that? Before that, can we just go back to the previous session and somebody can explain me what is supervised learning before we jump into unsupervised? What did we talk about supervised learning in the previous session? People who had attended, what was supervised learning again? Anyone? What was supervised learning? Output is fixed, all right. And what about input? Output was fixed and the input was labeled data, meaning for this you are getting this output. Over here, did I give you an output to be fixed? I did not say no. Group it on the basis of color, or group it on the basis of number of seeds, or group it on the basis of amount of vitamins, right? I just gave you a data. I did not label it. What is this? What is that? And you gave me an output. Were all your outputs varying? Yes. If you do it on color, change. If you do it on the number of seed, output will change, right? So that is called as unsupervised learning. So if somebody can summarize unsupervised learning for me over here, what is unsupervised learning? We know supervised was labeled data, output was fixed. If you can summarize unsupervised learning in your own words, go ahead. What do you think is unsupervised learning? Output can't be predicted, okay? Cool, it will be difficult to predict output in an unsupervised learning. What else? Anything for the input? There can be many assumptions, yes. Anything for the input, guys? Anything for the input? Output can't be predicted. There will be n number of assumptions to things. Anything for the input? for unsupervised learning? All right. So unsupervised learning is sort of a machine learning part where the algorithm learns to find patterns and structure in a data set without any pre-existing label or categories. What did you do? You were trying to find patterns. You were trying to find, okay, this is red, it'll go in one group. Or structures. Somebody said depending on the number of seed or the if someone goes with shape. So you are basically learning to find the structure. So find patterns or structures in a data set without any pre-existing labels. In other words, algorithm is left to discover. How I left you to discover on your own, that I am not giving you some specific output. Discover on your own, like what exactly will be the output, right? So all of these things come under your unsupervised learning. Now, there's a 5 minute assessment. Now that we know what exactly is unsupervised learning, I'm pretty sure just next to you, you have so many examples of unsupervised learning wherein you have unlabeled data and the output isn't predictable, or you are making assumptions, whatever you guys have told me. So take 5 minutes, it's 5:32. By within 5 minutes, I want at least five unlabeled data sets nearby. Go ahead. You want, you can put it down in the chat, or you want, you can maybe unmute yourself and tell it to me. Just nearby, next to you, you might, I'm pretty sure you might have five different unlabeled data sets around you. If I was supposed to give you an example, let me start with one. I have a laundry bag nearby. So when I'm sorting my laundry, I can either group, similar items together based on maybe their color, as you told me, or maybe based on material. Like these materials require a different type of washing and all. Or any pre-existing labels, like okay, this one is expensive, so I'll just group it in a separate manner, or this one is different, or maybe depending upon the way I wear it. So that was one example coming from me. I want four more examples coming from you guys. Come on. Look next to you and tell me if you have any unlabeled data sets next to you. Groceries. When you say groceries, can you just elaborate? Grocery bag, the same as laundry bag, is it? Plants. Plants. Can you elaborate, Gayatri, when you say plants? Box of jewelry made of gold, diamond, platinum. Yes. Indoor. Oh, indoor plants, outdoor plants. Okay. Cool. Grocery bags, box of jewelry is what we got, and the types of plants we have. A few more, guys. Come on. You might have so many next to you. Groceries based on price and uses. Yes, these are the two parameters we can group them on. What else? We have got three examples so far. Can we get one or two more? Others? Sakshi, Amruta, Samruddhi. Stationery, pens, notebooks, pencils. Okay, yes, sounds nice. Anyone else? Do we have any more examples? Beauty products, various brands and uses. Yes, of course. Brands, uses. Are you using it daily, or is it just for, function purpose? So that is how you try to segregate and store them. A few from my side would be, one more would be identifying friends' voices. Let's say I'm on a phone call with friend whose number is not saved. So I can often identify who is speaking even if they don't tell their name on their unique voice, right? So their voice is unique. I am able to either group them on the basis of their unique voice, or maybe their way of talking. Or some people have humor when they talk, right? So it is similar to identifying things in your learning as well. Then maybe recognizing handwriting also. When you write something by hand, your handwriting has a unique style and pattern, right? So all of these are just various examples of your unsupervised learning, based books based on subjects and concepts, Bookshelf, yes. Self-help books, autobiographies, yes, actually. This reminded me of discovering topics in a book also. When you read a book, you might notice that certain topics or themes just keep coming up. So unsupervised algorithms, unlabeled data can be used there also. Cool. That's great, guys. Amazing. So the assessment has been done. Now, I would just like you to give me, now that we have also learned about supervised and today we've had a walkthrough about unsupervised, can you give me just three differences that you observe between supervised and unsupervised? Let's first talk about supervised, which is that one parameter you would want to differentiate supervised and unsupervised with. Supervised. The first parameter of differentiation would be for supervised. You can go ahead with input, process, and output. Let's talk about the input of supervised learning. So, can we say anything about the input of supervised learning? Anything that, you know, differences it with unsupervised learning? Anyone? When we are differentiating between supervised and unsupervised, so what is the first parameter we should differentiate on? If it's the input, what can you say about the input? Label input for supervised, unlabeled input for unsupervised. Output is based on pattern. Cool. The first step is the input for your supervised learning is labeled. You actually have some categories. However, for unsupervised, it is just unlabeled data. It is just exploring an unknown territory, sort of without a map. Cool. Second thing, what is the second parameter you can differentiate on? Used for prediction, used for analysis. Amazing. So the supervised learning is used for actually predicting if you give this input, what will be the output because it has a labeled data. And the second one that is unsupervised is used for analyzing, basically finding patterns or relationships in the data without any predefined output, like how it was in supervised learning. Cool. One more. Can we have one more? With teacher, without the teacher? Yes. One short way of telling. Input and output are used for supervised, and raw data is used for unsupervised. School. So two of them right there, two differences. Um, Training data. Let's talk about one more, like training data. So in supervised learning, the training data, the one that you are feeding, consists of pairs of input and output, like a list of house and their price. Just an example. While in supervised learning, the training data that you are feeding to the model consists of only input, like list of house with their size and location. Predicting the output is not there. Then let us also consider performance evaluation. In supervised learning, the performance of your model is evaluated by comparing predicted output to the actual output. There is something called as accuracy. It's like, okay, exam ke baad I am thinking that my percentage will go about 85, but it actually came out to be, let's say, 83. So how accurate were you? So over here, the performance is evaluated by comparing predicted output to the actual output. While in unsupervised learning, performance is evaluated based on the model's ability to find these useful patterns or relationships in your unlabeled data. So these can be a few points of differentiation between supervised and unsupervised learning. So is this clear, guys? Is the foundation between both of them clear? The basic fundamentals. What is supervised versus what is unsupervised? Do you guys have any doubts so far about the supervised versus unsupervised part? Anyone? If you have no doubts, point out a no. If you have any doubts, point out a yes, and then also tell me what's your doubt. So then it will be easier to know. No doubts, okay. Others? No doubts, okay. No, okay, all right, okay, all right, got it. So if you have no doubts, then there is a quick quiz. What I'll be doing is on the Discord group, since I cannot share images over here, I'll share 10 images. What I want you to do is I want you to group them according to your own opinion. Now, these 10 images might be relatable, might not be relatable. That is how your real world data goes and all right. All I want you to do is just group them depending on your opinion. What you will do, did you guys see how Prajakta, I think Prajakta was there, right? Prajakta. She named the group and put in the like participants in the group. Just do that. I'll be pasting all of these images in the WhatsApp group. I hope everyone is online there. And what I want you to do is group one, mention all the participants in group one. Enter group two, mention all the participants in group two. All right. So let's begin. So group the items according to your own opinion. And I am in training sessions LPF, that channel. So give me a second. I'll share all the 10. Once I'm done sharing all the 10, then I'll just. Why am I not able to paste it? Okay. Okay. Just let me know if you guys are getting. Did you guys get the very first image? Because from here it is not going for some reason. If possible, put it on Discord if you can see the very first image, guys. These are random items I picked from the internet. Okay. So two done, eight more to go. Just give me a second. So putting just 10 images, group them according to you. You want color, you want their applications, anything else that I might not know of, group them according to whatever you wish to. Just make sure you write the group name along with the participants, and whatever groups you create, two, three should have all the total number of participants should be 10 in all. I've done, I guess, six. And when you are done, we'll come back into the Google Meet and just see what was your purpose of putting it into that group. Right? I guess I'm almost done. Cool. Two more. One more. There we go. I'm done with all the 10 images. The 10th one is just uploading. Just give it a minute. Let it rest for a second and then try. Cool. So I want you to create some groups. I'm not sure what number of groups you will create, but just create groups and then we can discuss. If I name them, there's a kite, there's a ball, there's a globe, or globe. Yeah, I think globe is better. There's a book. There are two boxes. Both have different characteristics. There's a diamond, there's a coal, there's a bag, and there are those rings. I'm not sure what you call them. Rings is what I'm calling them. Come on, quick. Aishwarya, Anushka, others are typing. Yanishwari, Komal, Kshitija, Navya. Cool, Gayatri is the first one. So Gayatri has grouped them based on age groups. First one is her age group for children. You have kite, ball, and rings. For geography of school, so we went into educational purposes. We have book, globe, and backpack. For storage, we have boxes. Then this is my first lecture. I have missed two, hence I'm not in the group. Sure, I'll just share the link over here, Pallavi, for the group. You can click on that link and join in from here only. Okay, there you go. Just click on this link. Let me know if you are in. For storage, we have both the boxes. According to carbon content, we have coal and diamond. Trust me, I did not think of diamond going into the carbon content, but thank you so much, Gayatri. So based on different colors, so what shall I is going with colors? We have kite, ball, and rings. Cool. Since it has multiple colors, Snehal, group one thinks of rectangular shape. So shape is what was our POV while we were trying to segregate. Kite, box, and book. Kite, box, and book. Okay. Things of rectangle. Things of circular, we have ball and globe. And irregular shape, we have diamond, coal, rings, and band. Hey, when you say circular shape, don't those rings come into circular? Okay, but I think you are considering all the rings. So okay, you consider the entire figure. Got it. Kshitija says based on geometry, we have black box, curtain, and book. Others, Aishwarya, Anushka, Jnaneshwari, Komal, Navya. Okay, Sakshi, group one, ball, glow. Group two, book. Where is group two? Acha, group one, ball, glow. Book, group three, book, kite, and boxes. But based on what, Sakshi? Group 5 diamond, group 6 coal, group 6 bag. Shape, okay, based on shape, all right. The ball and globe being circular, book, kite, and boxes, okay, being like a quadrilateral, I should say. Then we have diamond and coal and bag, okay, all right. Others, okay, Komal is typing. So if you see, you just try to do it under your supervision, under your own opinion. So that is what is called as you finding out the output based on unlabeled data that I give you. So you basically performed an algorithm, you grouped them, you analyzed it depending on various parameters. Okay, people are still typing. Until you guys type. So that was a great participation from all of you. Keep it up. Let's keep that for all the other sessions going ahead. So whenever we talk about unsupervised learning algorithm, people who are typing, you can still type. You can just hear whatever I'm saying. So if you have gone through the lessons, both the lessons, unsupervised learning algorithms and reinforcement, you might have come through terms like clustering, dimensionality reduction, anomaly detection, etc. These are all the algorithms of unsupervised learning. So if you have gone through these lessons, can somebody tell me what exactly do you mean by clustering? Light and weight ball rings, cool. So another POV that we have is depending on the weight. Amazing. So if you see, there are so many different ways you have actually tried to group them. So you basically are performing your own algorithm, sort of. Amazing, guys. That was pretty amazing. So when we talk about unsupervised learning algorithms, the first one is clustering. Guys, any of you, can you tell me about what is clustering? Anybody?
Collecting.
Collecting, all right. So clustering, a basic meaning is collecting. Cool. Anybody else? Do you guys listen to Spotify music? So how do you actually search for a grouping of inputs? Yes. So if you have been to Spotify or any other music app, how do you search for a song? Do you search for the artist, or do you go to a playlist searching for happy songs, party songs, collecting, gathering? Yes. So you see, there is a grouping done. Let's say there is an artist you want to listen to all, let's say, Post Malone songs. So you search for the artist, and then all the these things come, right? I mean, all the albums and the songs come. That is what is clustering basically. It is the technique to use used to group similar data points based on their characteristics. It is used to identify patterns or similarities without any prior knowledge. The way you did was clustering. It is often used in marketing to segment customers based on their purchasing behavior. Example, if you have a data set of customer purchase behavior and you want to group like similar customers together based on what are they buying. So using clustering, you could group the customers who purchase similar projects, and then this information can be used to target marketing campaigns for each group. So that was about clustering. Yes, based on various parameters, we gather and collect them. What about the second one? Dimensionality reduction. What is dimensionality reduction? Anybody? Dimensionality reduction? No? Okay. So it is the technique used to reduce the number of variables in a data set while still retaining as much information as possible. This basically helps in simplifying the data and making it easier to visualize or analyze. Example, if you have a data set of images with, let's say, thousands of pixels per image, using this technique of dimensionality reduction, you could only extract the most important features of the image, maybe like the edges or the colors and the textures, and represent the image with the small set of features rather than having big unnecessary set of features. So this would make it easier to visualize patterns. How you highlight the main points, or you get question banks, no, for your this thing exam. So you do not have to look at the unnecessary information. That is basically dimensionality reduction in terms of machine learning algorithms. The last algorithm that we have is anomaly detection. Anybody? Anomaly detection. If you have read the lesson plans, what is anomaly detection? No one? Data which shows rare behavior or different behavior. Amazing. So, when you have data points which are different in behavior, so anomaly detection is a technique to identify data points that are significantly different, or in your words, as you said, rare from the rest of the data. It is used to identify unusual or unexpected behavior in data. It is usually used in fraud detection or network intrusion. Example, you have a data set of, let's say, cards, credit card transaction, and you want to identify the transactions they are likely to be fraudulent, whatever. So using this technique, anomaly detection, you could identify transactions that are different from the typical transaction, that are rare or that are not very common in the data set, such as transactions maybe with a large amount of data, large amount of money from an unusual location and all of that. When your account gets hacked, you might have seen many times the account get hacked from a country you don't even know of. So that is what anomaly detection will help. Finding the outliers, yes, finding the rare values. So these are all the algorithms of unsupervised learning, the three of them: clustering, dimensionality reduction, and anomaly detection. Now based on all of this, there will be a quiz. All right, so as you know, our quiz nature is, I'll be sharing the questions on this thing, on the Discord chat. What I want you to do is I want you to answer it there. But this question quiz is slightly different. I won't be giving you MCQs for this particular one. What I have thought of, I'll be giving you various scenarios. You tell me in this scenario which one would be fine. Like unlabeled data would be fine or labeled data would be fine. So I'll be putting the scenarios in the Discord. Think about it. Take a minute or so for each single scenario and then tell me which type of data would be fine. Labeled type of data would be fine or unlabeled type of data. All right. So pasting the first scenario in the Discord chat, what type of data would suit in the following scenarios is the question. Labeled or unlabeled? So scenario one, there's a company who wants to analyze customer feedback to improve their products and services. There's a company who need to analyze customer feedback to improve products and services. Unlabeled, okay. uh, I will group you guys now into labeled and unlabeled, whatever answer you give, and then you tell me why unlabeled and why labeled, okay. Just don't say unlabeled because there's a word analyzed. Think about it also. When you say feedback, first of all, customer feedback, what does it mean? What do you mean by customer feedback exactly? First think about that and then think of which data would be useful. Are you sure unlabeled data will help the company to analyze the customer feedback? Because if it is unlabeled data, do you think company will know how to group them? Labeled, okay. So three unlabeled, one labeled is what I'm getting. Because in order to improve their products and services, customer feedback is basically, let's say, talk about stars. So 4 stars, 3 stars, 2 stars. If it is not labeled, we'll be sorting it in any way. Then how exactly will we be able to improve our services according to the customer feedback? Am I correct? Labeled is more effective. Huh? So if you have a labeled data, let's say positive, negative, or 4 star, 5 star, that is when it will be more useful. So in this scenario, label would be useful. Company would ask the customers to provide ratings, let's say positive, negative, as you said, or stars. So for their feedback, which would be having some pre-existing labels that could be used for supervised learning. So with the label data, the company could train a machine learning model to automatically classify the new feedback. Now, let's say I have one more scenario. Don't worry, we won't have many, just one more. The scenario, a research team wants to analyze satellite imagery to study changes in the environment. Now, think about if you are working in a NASA, do you really think you would have labeled data? Meaning, do you really think you would have categories or no? Because when you are in space, every day a new discovery is made. So, think about this a little. Unlabeled. Okay. The first answer we are getting from Snail is unlabeled. Sakshi says unlabeled. What about others? Two for unlabeled. What about others? What are you voting for? Labeled or unlabeled? Others are not voting for anything, it seems. Okay. So in this scenario, yes, unlabeled data would be useful. Satellite imagery would not like have any pre-existing labels or categories, right? There is not a possibility of that. And the researchers would want to use unsupervised learning, such as maybe clustering or dimensionality reduction to identify patterns and anomalies in the data. So yes, all of you guys over here are correct. We'll have unlabeled data. One last scenario for you guys. Scenario three, a healthcare provider wants to predict which patients are at high risk of developing a particular disease. So when you talk about healthcare, what do you think? Our labeled data would be useful? Labeled, labeled. Cool, very good. So in this scenario, a healthcare provider could gather data on patients who have already been diagnosed. No, so when pandemic came in, they were only checking, okay, if you have these four symptoms, then for sure you have COVID-19. If you guys know of, so that is labeled data, meaning they knew the input and what is the output. So if he knows, I mean, if the healthcare provider gathers information who have already been diagnosed and patients who have not been diagnosed, so what are the symptoms and the cause for that? So all of these things will be covered up in your labeled data. So that was great, guys. So I hope the difference between labeled and unlabeled data is clear. Now, just before we go for a break, for a 10-minute break, let me take a moment to share something with you. Just a second. I'll share my entire screen with you guys. I would want to show you something. I hope, yeah, it's visible. So when we go to Discord, just letting you know, we have different one section. We have different channels for you guys. There's one channel, job listing. So here you will find all the jobs that might be suitable for you in the future as well. So just go through them, open it, look at the requirements, look at what they are looking into the candidate. So just have a look at them, because LinkedIn, we have created a profile. We created a profile and all of that just to make sure that you are landing on a proper and perfect job. So just have a look. They might suit you. Then there is AI news, wherein some of the other news is put like what are the new inventions of AI. Then we also have something called as, one second. Yeah, this channel coding. So this would help you to understand some basic terms. These are all the terms that they'll ask in the interview. These are not the terms they'll teach you in the college, though. Just saying. They won't tell you DevOps, what are design patterns, what exactly are microservices, and what are the services. Cloud computing, yes, they'll tell you everything is on Alexa, AWS, but they won't tell you the real meaning of it. So just for a deep dive into, just have a look at all these articles and just get the knowledge, because when you are in the interview, all you remember is what you have studied in your college. You won't remember things others. So just have a look at them, read them, so that it retains in your memory and then you can use it later on. And then there are some ebooks that you can actually have a look at. So they are based on AI only. So just these few things um, I wanted to show you, so that you have a clear understanding of what the channel is actually supposed to bring things for you. All right. So please, whenever you get time, have a look at them. And yeah, that's pretty much it. So let's take a small break, guys. I think 10-minute break should be enough. So it's around 6:04. 6:14 is okay for all of you people. Is 6:14 fine? 10-minute break. Let me know if that is fine, because we have to finish this wrap up by 7. Yeah, all right. So before you go, please just fill up the attendance form. I've shared it here. And when you open it, please let me know if it has access. I've created at the go at the end, okay? Go at the end and then try to put start from line number 68 or something. And at the end, just also add the location. I've added one more column, guys, at the end. Just put the location of your college. That's it. Because some of you at the top have put the location, but since we cannot go back and try to modify it, just put one extra column over here. Just try to put the location of your college as well. All right. So I already see people filling it up. So let's meet by 6:14. Okay. Let's be back by 10 minutes. Get some water, take a little bit of rest, and be back. Okay, I think all of you guys are back by now. Did everyone also fill the attendance form? I'm figuring out some of you still haven't. I can see 14, but in the meeting we have around 80 to 20 people. One of them is me, but just make sure that you guys fill the form, okay? So are we guys back? Should we resume? Should we start? Should we start, guys? Yeah? Okay. All right. Cool. Just fill up the attendance form real quick. Let's start. So we had a look at unsupervised learning. Let's have a quick look at reinforcement learning. So we'll just have a look at yet another type of machine learning, probably the last one, reinforcement learning. And we'll just have a look at its algorithm. So, before we actually go into the depth of it, you guys tell me, you play online games. Sometimes you play it with your friends. Sometimes your friends are too busy, and then you play it with computer. Let's say you are playing chess online. Okay, how do you think the computer learns? Does the computer win or do you win? If you have played any online game with a computer, let's say Ludo or chess, what happens? Do you win or does the computer win? Usually, what happens? Do you win or the computer win or both of them? Who wins? Do you win when you are playing any online game with a computer? Do you win or does the computer win or there is a possible most of the time computer wins, computer, okay, based on probability, okay. Then in the second scenario, if you have ever trained a pet dog to do the tricks by rewarding good behavior and punishing for bad behavior, have you ever tried it? Have you ever trained a dog and if like he does good things, so you treat him with treats and some rewards, and if he does any bad things, you actually go and hit the dog or punish him for the bad behavior. Sometimes we win and sometimes the computer win. Yeah. So if you see over here, you said most of the time computer wins. So what happens, no? In online game, this is an example where the computer learns from the outcomes of the moves. If you are playing, then the computer is playing something. Let's say the computer lost, so now the computer has to make decisions on its own. Okay, I lost, so how can I try to improve my gameplay, right? So in the first scenario, the computer is trying to learn if the computer loses. So it learns, and after some point of time, now it has learned so much that most of the times the computer will win. In the second example, the pet learns to perform certain behaviors because you treat him with some rewards, and he would avoid the behaviors that for which you would give him punishment. So basically, he would not require punishment, so he would avoid that behavior. So both of these are technically examples of another machine learning algorithm called the reinforcement learning. So now, if we just try to have a look at these two examples, and then we can try to summarize or debrief the reinforcement learning. What do you think you can say about reinforcement learning? Both of these examples were based on reinforcement learning. So if you consider these two examples, what can you say about reinforcement learning? For supervised, we know it's a labeled one. For unsupervised, we know it's an unlabeled one. We can predict the output, we can't predict the output. Can you tell me something about reinforcement learning? What did we actually get from the two examples that we had a look at? Come on. What is reinforcement learning? Connect the dots with the example that we just did. wherein the computer was also learning from its own mistakes, and so was the dog learning from, okay, if I'm doing this, human is giving me some treats, and if I'm doing that, the woman is giving like punishments to me. So can somebody summarize um, reinforcement learning for me real quick? No one? Computer learns from real life interaction, yes. So reinforcement learning is basically that, wherein it is a type of machine learning algorithm where computer, or we term it as agent, okay, learns to take actions in an environment to maximize a reward. If you win, that's a reward for you, right? That is what reinforcement learning is. It is a type of machine learning algorithm where machine learning where agent learns to take actions in an environment to maximize a reward. Agent receives feedback in the form of rewards or punishments. If the computer loses, he might lose the points or something. If the dog loses, let's say, so you give him some punishment. So the agent uses this feedback to learn and improve its behavior over time. So now that we learned about reinforcement learning, can you take a couple of minutes and try to give me three examples, maybe in your daily life, wherein you see reinforcement learning? Think about it. In which set of your daily life do machines learn from their experience? If anyone is a gamer over here, you might be able to relate it some way with your gaming. Also, think about it. Take a couple of minutes, up to 5 minutes, and think where exactly is reinforcement learning used in daily life. Machine learns similar to human psychology. Yes, that's reinforcement learning. It's just that it will take feedback every single time. Yes, guys, come on. Where do you think we use machine learning in our daily life? Sorry, reinforcement learning in our daily life. Think about it. Robots used in food restaurant. Okay. Can you just elaborate a little bit? So are they how exactly are they learning from their experience over here? Recommendations, marketing and advertisement, yes. Recommendations, when you're gaming, when you're talking about recommendations, let me tell you, you have that option of do you know this person? If you're like, no, do not show me these recommendations, right? You have seen, or do not show me these ads. So you are trying to tell it like, okay, I do not understand these ads, so it takes the feedback and then tries to avoid that, right? Then we have marketing and advertisement. Yes, amazing. We have gaming. Just one, Aishwarya. Robots used in food restaurant. Can you just try to elaborate how is it learning from its experience? They deliver food to tables. Okay. Mm, but how is it learning from its experience? If you can just elaborate that. So the few examples you gave me was personalized recommendations, online platforms, Netflix, Spotify. Both of them use reinforcement learning to learn from users' viewing and listening habits to make personalized recommendations. Gaming, someone said. So many video games also use reinforcement learning to train the behavior of non-player characters. NPCs you might have heard of, right? In order to train the behavior of these NPCs to make it more challenging. Okay, you are playing, there's this NPC, you just kill it. So it is taking feedback that, okay, I am not that strong. We need to make the NPC more strong, non playing characters. It is also used in autonomous vehicles like self driving cars to learn from the feedback received from their sensors to make the decisions about how to navigate roads and avoid obstacles, traffic. Advertisement, someone said, yes, they also use reinforcement learning to optimize their advertising campaigns based on behavior and feedback. Basically, the goal of maximizing a return on investment for advertisement. Alexa learning from different inputs and trying to give more accurate output. Yes, natural language processing is also an example where reinforcement learning can be used. Amazing. So if you see in daily life, we have so many places where the reinforcement learning is actually taken into picture. Now, when you talk about reinforcement learning, there are also some algorithms for this reinforcement learning. You might have seen them in the lesson plans again. So the first one is Q learning, we have SARSA, and we have policy gradients. These are the well-known learning algorithms for reinforcement learning. So let's start off with the first one, Q learning. Let's have a basic overview of that. So anybody, what exactly is Q learning? Anyone? Q learning? No one? Okay. So in Q learning, what happens is the agent learns a Q value. Now, Q value is used to determine how good an action is taken at a particular state. So action and state, when you combine them, that is when you get a Q value. So the agent learns a Q value when action is good at a particular state, representing the expected reward for that action. The agent then selects action based on the Q value, that okay, this action is suitable for this state, then I'm taking a decision. So it will keep updating the Q values, no? Because some action might be suitable in some state, but some action might not be suitable in other state. You are saying congratulations to a person who just finished an exam, but you cannot say congratulations to a person whose birthday it is. So what action should be suitable on what state is what your Q learning is all about. One example is teaching a robot to navigate a maze by a trial and run error, learning which paths lead to the rewards and which lead to penalties. They can change, right? Both of them can change. The um, turning left, moving right, these are all the actions, but they will only be suitable for a particular state. No, if there is a turn in the maze, only then your robot can turn. If there is no turn and you are asking the robot to turn, how will that work? It will lead to penalties or maybe shocks given to the robot. So Q value basically means how good the action is provided at a particular state. So if there is a turn, only then do the action turn, then only it will be beneficial. That is what your Q learning is all about. Then we have SARSA also. SARSA is yet another Q learning algorithm wherein the agent learns to estimate the Q value of the current state action pair and updates it accordingly. So in SARSA, the agent learns to estimate the Q value, like how good an action is depending on the state, and it keeps it updating. SARSA is an on policy learning algorithm, which means the agent learns from the policy it is currently following. One example can be self-driving cars to stay in its lane by adjusting, shear angle based on the road's curvature and the car speed, etc., etc. So that is about SARSA. Again, it is learning, right? The agent is learning like which action will be better in which state, but this is an on-policy algorithm. So SARSA example would be a self-driving car, like a proper self-driving car that is being tested to stay in its lane by adjusting the steering angle depending on speed and the curvature of the road. Last but not the least, policy gradient. Policy gradient again is an example that learns a policy directly, mapping states to action without learning the Q values. Over here, the Q values are not taken much into consideration, like what action will be suitable for what state. It mapping states to actions directly without actually having a look at the Q values. The agent updates its policies by adjusting the probabilities of the selecting actions in each state, maximizing the expected reward. One example of policy gradients could be teaching robot to walk by adjusting its joint angles based on the position and the velocity of its limb. Now it is just walking. There is no okay which action will be better in which state. It is just walking. So policy gradient is teaching the robot to walk by adjusting the joint angles, which is based on the position. So in here, the Q value might not be taken much into consideration. However, we can just, um, map the states to actions directly without checking key, okay, this state might be the best suitable. So in here, since the Q value is not taken into consideration, policy gradients might take a little bit of more time. But in some scenarios, yes, policy gradient is like the go-to place when you do not really care about the Q value, how good the action is taken on a particular state. All right. Now that we have learned all the three types of learning, the supervised, unsupervised, and reinforcement learning, what do you guys think? Is supervised learning like used for all of them? Meaning, if we use supervised learning for all the requirements in our life, will that be okay? Or if we use unsupervised learning for all the parameters, will that be okay? Or reinforcement? Or do we need different stuff, different time? What do you think? Can a world just run on supervised learning or unsupervised? Can we just take one or what? We'll be using a combination. Think about it. Can we just run the whole AI domain on supervised learning or no? Come on. Reinforcement learning is widely used, okay? What about the other two? Are they also used, or if we just use reinforcement learning and base our AI domain on that, will it work? The entire learning only on reinforcement. Let's say we are not taking into consideration supervised and unsupervised. So will it work? Because in reinforcement, supervised learning can be used for small projects or a specific project. Okay. What about unsupervised? Others, what do you think? If we just take into consideration one of these learning techniques, can we survive on just one? Can the entire AI survive on just one learning technique? Or do we need to have a combination of all of them? Come on, think on it. Unsupervised learning, if used with reinforcement, will be more effective. Okay. Unsupervised combined with reinforcement. Okay. So if you see, when you say best approach, so let's talk about supervised learning. If you have a labeled data, which many of the times you might have, many of the times you might not have as well. So if you have labeled data and a clear objective or the target value variable, like what is to be predicted, supervised learning can be a powerful tool for building accurate predictive model. Your results, you have labeled data, no? These are the marks for viva, these are the marks for final exams, the written exams. This is for, let's say, VLSI, this one is for, let's say, design engineering, this one is for, let's say, some subject that I do not remember now. So it's like you have labeled data in the input. You want to predict the CGPA or the SGPA. So at that point of time, you will use supervised learning. Unsupervised learning, if you have large amount of unlabeled data. Now in here, you just have an unlabeled data, no categories whatsoever. And you're looking to identify patterns or structure within the data. So then unsupervised learning may be a good choice because at times you want to identify the patterns or structures so that you can use it for the stock market and all of that. So that is when your unsupervised learning comes into picture. Whereas, let's talk about reinforcement learning. If you are trying to teach an agent to learn how to take actions, as you were saying, it is widely used. So, in order to maximize the reward, we use reinforcement learning. We have seen the examples of all the three of them, right? We spoke about supervised learning in the previous session. Today, we also spoke about unsupervised and reinforcement learning. So, these are, the things you need to keep in mind. When to use what, that should be clear. So this was sort of the end of the different ML algorithms. Now, before we go to the actual quiz part for today, you guys tell me if all the three machine learning parts are clear. Are you clear with supervised and unsupervised and reinforcement, like the basic fundamentals? The algorithms, guys, they are present in the lesson plans. We just had an overview over here. but I think many of you guys have not really gone through the lesson plans since no answers were given during that. So I would just request you to go to the lesson and have a detailed look at the algorithms that are given. For AI, reinforcement learning is beneficial. Yeah, because you train the machines to learn from their own experience, right? So when you talk about AI field, so yes, reinforcement learning is much beneficial. So here's a request to please have a look at the lesson plans for the detailed algorithms. When I say algorithms, I'm talking about these, the Q learning, sign policy gradients, and all of that. So before we go into the quiz part for today, the last quiz, are things so far clear to you guys? Are we clear on supervised versus unsupervised versus reinforcement? Clear? What about others? Where's Amruta, Samruddhi, Kshitija, Navya, Sakshi, and all the 10 others whose names technically I'm not able to see? Aishwarya is there. Others, any doubts before we proceed? Okay, all right. So, here's a quiz, the last quiz for today's session. So, I'll be sharing the questions on our Discord channel. All right, it's clear. Good to know that. So, I'll be sharing the questions on the Discord channel. What I want you to do is, I want you to put the answers over there A, B, C, or D. This one, for this quiz, I've kept the answers a little bit bigger usually than what we have. So let's go ahead. I think Pallavi just joined, right? So Pallavi, you have to go to training sessions LPF channel and then try to answer the questions. So I'm sharing the first question of the quiz in the chat box. Go ahead. We are around 10 people over here. So I would need 10 answers. Until I'm not getting 10 answers, I'm not giving the next question. Go ahead. What is the main difference between supervised and unsupervised learning? Please make sure you are reading it correctly. One, two, three. Okay, so one, two, three, four, five, six, seven, eight. Who are the two more people? So nine. Who is the one more person left for answering? 10. Okay, cool. So A, wherein supervised learning is using labeled data, however, unsupervised is learning, the other one. Clustering is a part of which algorithm? If I just go ahead and just number them for you guys. So we have A, B, and C. Clustering is a part of clustering means collecting and grouping. Are you sure it is a part of supervised? Because what are you collecting? Aren't you already getting a collected or labeled data? Prajakta, Kshitija, Gayatri, Jnaneshwari. Aren't we already getting a collected data? For supervised, it's a labeled data, meaning it is already collected into some groups, right? Okay. So B, cool. B is the correct answer. Jnaneshwari, Gayatri, then Kshitija and Prajakta. Because collecting in this thing, supervised learning, we technically do not collect, right? We have already this thing, the labeled data. We collect it in unsupervised because you have to cluster it, you have to group it, and then put it into under some labeling, right? Third question. There you go. Please make sure you have a look at this very in depth. So, in which of the following scenarios would you use supervised learning? Identifying patterns in unlabeled data, recommending products to customers based on their past purchases, clustering similar customers together based on their demographics, identifying anomalies in network. So, okay, two answers for B. third also for B. 4, 5, 6, 7, 8, 9, 10. Okay, so B because I recommending products based on their past purchases. Meaning past purchases, we already have the inputs, right? And we are trying to predict if the output we are getting is dependent on the past purchases, which is our input. So input is our labeled data. Let's have one more. What is the main difference between reinforcement learning and other machine learning models? When I say other, I mean both of them, supervised and unsupervised. Okay, the first answer we're getting is C from Sakshi. C from Komal, Prajakta, Gayatri, Samruddhi, Kshitija, Aishwarya, Pallavi. How many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Two more people? I think we are done. My math is not that great. Cool. So C, wherein reinforcement learning involves an agent learning from trial and error interactions, experience or trial and interaction one and the same with an environment. So that was it about reinforcement learning. And I think today we took a lot of quizzes and there was a great participation from you guys. And yes, I would say almost all the answers were properly answered and correct from all of you guys. So if we just summarize the things we have done today, we had a look at unsupervised learning first of all. We tried to uh, check the difference between unsupervised learning and supervised learning first. We had some examples of unsupervised. The next thing we did was had a look at reinforcement learning. We also had a look at both of their algorithms. So unsupervised learning algorithms we had a look at reinforcement learning, unsupervised at clustering, dimensionality reduction and anomaly, reinforcement at Q learning, SARSA and all of that. So these algorithms, guys, please make sure that you read it from the lessons. That would be great. And we also had some quizzes. Now, before I share with you the batch and the homework, I have given the feedback form link in the chat. I hope everybody has, in this chat only, in the Google Meet chat. I hope everybody has gotten it. So, the first thing I want you to do is please go ahead and try to fill it before we actually go to the homework part for today. And once you are done, please just let me know. Then only we'll proceed. Is the feedback form accessible to you guys? Please have a look. No? Okay. Link of the Discord channel. Sure. Here you go, Komal. Please join and let me know if you are able to join. People once done, no? If you are done with filling the form. Do let me know. Done with the form. Okay. I think almost everyone is done. Done, done. Or do put in some suggestions if so that we'll also try to improve. We are also trying to do reinforcement learning in our daily life. Just saying. Done. Okay. Seems like everyone is done. Okay. So if everyone is done, so this was our third session. So let me just share the link of the batch. I'll share this on Discord so that you can get it and download it whenever you want to. And this one is accessible. Don't worry about it. So you can just download it from there. So I know some of you are already having exams and all. So I would suggest once the exams are over, then have a look at the homework. Okay. So before we go to the homework part, one last time, feedback form session. I know we are planning to continue the feedback form the same for all the sessions so that we can have the same Excel file to track it. Else we'll have more than one Excel file. That's why. Good observation though. So before we proceed, is there anything unclear in your mind? Do you have any questions that you want to raise right now at this moment that I can answer? Sure, I'll do that, Pasha. Just give me a second. Anything that we need to ask, guys, before we actually proceed to wrapping up? Anything still unclear in your mind? Any doubts? Okay. A pin drop silence is considered as no usually, so okay. All right. So we'll have a couple of homeworks today. Don't worry, this won't take much time. It is not much about code. So for supervised learning, image classification, what I want you to do is collect different pictures of animals and categorize them based on their species. I have a proper output. Like I want them to be on the basis of species only. That will be my very first homework 1.0. For unsupervised learning, clustering. Take different fruit images, or if you want, don't take images, just take the names of them and create groups depending on whatever parameters you wish to. Over here I have just mentioned color, texture, or taste. You can have so many things that you mentioned earlier. For reinforcement learning, now this one is fun. I want you to create a choose your own adventure story. You might have seen Jumanji and all of that. So how they have, if you do this, you will get this reward or this penalty. So write a choose your own game, own adventure story, where let's say I'm the reader. Okay, so I am like the main player, a main character of the agent, and I have to make decisions at each step. The outcomes of each decision will determine the rewards or the punishment for the reader receives. So create a sort of board game. Just create a plan. Don't create a board game. Don't sit and have a cardboard and then try to put it. You can do that after the exams. So create your own adventure story wherein it is sort of like a board game, wherein the agent is the reader and he has to make decisions. And depending on decisions, there will be different outcomes, either a reward or a penalty. If you have seen Big Bang Theory, the series, then you will come to know the board game I'm talking about. So you can create your own rules and regulations for that. So these are the three homeworks, small homeworks. I'll be sharing the screenshot of them in the Discord also. Don't worry if you just forget. So I think, yeah, that's it for today. And for Suvarchala, let me just show you something. And for anybody who has missed any of this session, I'll just share my entire screen with you guys. I hope it is visible. So what you can do over here is just go to your YouTube and search for. Okay, once you are done, I I had shared the link also. So if you see in those videos, no, you this one was for session 2. You will also have session 1. So just search for WiselyWise and you will get the videos recorded from the sessions previously. This is for everyone. I have also shared the YouTube channel. I'll share it on Discord also, just for your like convenience. So just go ahead over there and try to have a look at the video. All right. So virtual and others. Is that cool? Can we send the PPT link? Yeah, it's okay. You can send it all together. That would not be an issue. Just keep it on your GitHub so that in future, whenever you are presenting this as a profile, it is available to whoever you are seeing. Okay, that should be great. All right. So thank you guys for attending the session. I hope it was cool. In 2, 3 words, if you can just mention in the chat if it was okay, good. So even I'll be a reinforcement learning for today and learn from your feedback. People are pretty tired today, I see. Are we typing it on Discord or something? Oh, you guys. Okay. All right, never mind. So keep your engagement on Discord. Oh, thank you so much, Prajakta. Means a lot. So then I'll see you guys in the next session, which is on. Thank you so much, Suvarchana. Which is on Friday. So let's meet next Friday, guys. Please do remember you have a homework to complete. If in case you do not have exam, please try to submit it before Monday 6 p.m. Okay. Thank you so much, Shatija. So let's meet soon. Till then, have a great weekend ahead, guys. Take care and all the best for your exams. Goodbye. Thank you, Gayatri. Have a nice day ahead, guys. Thank you. Bye bye. Let me just stop the recording and then we shall. Yeah. Thank you so much. Have a nice day. You too.